Hello, this is another tactical technician video from Diagnation. Today we're going to talk about PCM controlled charging systems, in particular on the Honda unit. Honda was one of the first car manufacturers to use a PCM controlled charging system. I can remember far back as about 1990, where the PCM has a lot of input about how the alternator charges. Sometimes it actually cuts back and it does not charge. It's not an automatic every time. There are times when you may see a running Honda at 12.6 or 12.7 volts at the battery, and it's not broken. That's just a strategy of the PCM. It senses current flowing through something called an ELD unit. You can see it right there. You can take a snapshot of this schematic, this illustration. That's called an electronic load detector. It is in the underhood fuse box. It is basically a low amp probe that's part of the car, and you can see it here. We have it's in the fuse box. You can't really see it on the car. It's underneath. We are at the PCM where the ELD feeds a 0 to 5 volt range sensor. It's basically a transducer. It's got power, ground, and a 5 volt range signal dependent on how much current is actually flowing through it. And the PCM uses that to control the charging of the alternator. And basically, we're going to concentrate on a certain wire between the PCM and the alternator. Honda calls it the alternator FR terminal. I would imply that means like field regulation. And we're going to look at that terminal. It is a duty cycled signal from the PCM to the alternator, and then internally to the voltage regulator, which ultimately does the regulation on command from the PCM. We're on 4 signals here. Channel A blue is high amp clamp around the output of the alternator. B is at that duty cycled regulator signal at the alternator. C green is at the PCM at the ELD input to the PCM. That's going to swing in a 0 to 5 volt range, kind of like a TPS or a MAP sensor. Yellow channel is a micro clamp, and that one's we're going to look at the amperage flowing between the PCM and the alternator. There is a little connector there, and I want to get on both sides of that connector. I'm going to disconnect it to see where the who supplies the voltage. Because so many times when we diagnose charging systems, we got to make sure that that signal's good. I've seen a lot of people run into issues with alternators where that circuit is broken or something's amuck with that. So many cars today using smart alternators are using the LIN network or a networked communication right to the alternator to control charging from a BCM or a PCM. Also be mindful that the charge light on the instrument cluster is that validation that the alternator is charging is going to go through a network to the gauge cluster. Anyway, let me go to the scope, and then we'll start the car, and we'll talk about just an idling signal, and then make an analysis. Okay, here we go. Okay. Okay, we're on the scope now. Open this and start the car and talk about it. Okay, we're rolling across the screen. Well, now we're not. We gotta stop the scope. All right. Now we're rolling across, and let's just take a look. And I'll stop the screen, and we'll just talk about each signal and what they are. Let's just okay. I'll stop the scope, and this is basically our 4 signals. I want to get the yellow guy up. That's our micro clamp, and that is where is that? Okay, maybe it's in a bad spot. Okay. Zoom in on this. Okay, we can see what we're going on. We see duty cycle in the red. That's between the PCM and the alternator. Green is our input voltage from that electronic load detector, and that's running about 3.6 volts. We're going to see that change when a load changes. Our alternator output in current, right, our high amp clamp at the alternator, we're running about 20 amps coming out of the alternator, and we can see our duty cycle, the current of our duty cycle. This tells us something that we know we have a circuit that's complete between the PCM and the alternator, and they're kind of running over one. I would imply that this thing, the power is coming from the PCM to the alternator, and the regulation, the electronic regulation inside the alternator is grounding it. Basically, that's the signal right here. That's the current flowing. So nonetheless, I just want to do something to talk about a situation we may be involved in. Sometimes when there's communication between modules, we want to know who's sending the voltage and who's receiving the voltage. So right now, we're running, if you look at your illustration, we are on the red channel. On the red channel, we are on the PCM side of that connector, okay? I'm gonna break the connection and put it back and put it kind of jostle it on and off just to see something, to prove out who is the supplier of the voltage. Okay, let's stop that and take a look. Basically, we're on the PCM side. I broke the connection, and we can see our voltage remained high. That's just one of those things where sometimes we want to know where the voltage is 5 volts coming out of the PCM, so it's not coming out of the alternator, or where the PCM will be grounding it. I believe that the regulator is doing the grounding. Obviously, that makes sense. We stopped flowing current when we broke the connection between the alternator. There's our current flowing and our voltage regulation, then it stops, and then we plug it back in and it continues on. Anyway, I want to get back. I'm gonna go in the car now, and I'm gonna make some what I'd call load swings. I'm gonna make some I'm gonna go inside, and I'm gonna turn a bunch of accessories on, and I'm gonna get a little RPM. I'm gonna do it all in one shot, maybe 2 times. I'm gonna get the headlights on, the blower, the rear defroster, brakes, the AC, and I'll roll the power windows up and down a few times, and I'll raise the RPM, and then we'll kind of analyze it. I just want to go to a longer time base so we can be able to analyze better. Okay, I'm going in the car, and you'll see it. Okay. On the brake, high beam, blower, rear defrost, AC on, power windows. RPM. Everything's gonna go off now. Let's see it back to normal. Take a look at that event there. Okay, we'll stop and go back and analyze. Okay, here we can see, wow, we went north of 100. We clipped it. I probably should have scaled a little higher on the amp clamp, but nonetheless, you can see it going pretty high. We can see let's get some filters in here. We got a lot of hash. And then on blue, we'll get filter. Blue, okay, there's our current. Let's get the current clamp in here, that little micro clamp. And then we can see us going down on the, during that period when electricity, the amount, you can see our current changing. And we can see where we are. When I add the electrical load, right here, we're going up on current. We can see our current going to, right here, we're around 47 amps, and we go down here about 37. Duty cycle is changing. I will, if I have enough life, make a math channel so we can analyze the red duty cycle coming from the PCM to the alternator. We can see our current flowing through flowing from the PCM to the alternator. Our green guy, again, let's go to another section where it makes a pretty good change. Looks like green is low there for some reason. There, green comes back. green is right there, and probably a small voltage, but it's basically like a 0 to 5 volt transducer. That's at 2.7 volts. That's that ELD telling the PCM how much current's flowing through the system. Our current flowing out of the alternator, right there you can see we're at 96 amps. Right there we're at 60 amps. Right there we're at 45 amps. And right there we're at about 28 amps. So the regulation is all kind of corroborating with our green signal. Let's get a little math channel in on red, see if we can get we can look at that duty cycle change as we go through the load change. Okay, duty B for boy. Next, we're going to go black, and then we're going to play there. Finish. Duty B. Okay. All right, we have a math channel. Now let's kind of analyze that. Is that math channel? Okay. Well, okay. We're blowing in the wind here. Okay. All right. We're going back. Okay, you know what problem is? I got a filter. Yeah, good point here. I just want to make when you want a good math channel, you got to filter. See that? It makes it a lot better. May have to restart it. Tools, math channel. Take that off. Take that off. Go back. I'm not guaranteed with this thing. Duty B. Well, now we're still got a hashy math channel. Nonetheless, our duty cycle's changing quite frequently. You can see the duty cycle change on red. And the math channel just basically validates the duty cycle. When we go through a charging, a change, when a command from the PCM to affect the alternator. We can see that right here. Here's a more of an easier one to look at. Our duty cycle here on the math channel right here. We're looking at 29%. Let's see what we got about right here then. If that looks like 29%. Okay. We're filtered. Okay, that probably looks about 29%. Let's go back to a different section of the math channel. Right here we're about, okay, no, let's no. Let's go here. About 15%. So let's look at the math channel here. That looks like 15%. It actually looks, we look at that. Okay, let's get the filter off so it's more square. That looks about 15%. Just with a naked eye, we can infer that's about 15%. 15 of 100, that's the distance. So nonetheless, that's our math channel, which is helps us as far as you look at the amount of duty cycle as the charging system changes through the different commands of the electrical system. The PCM is pretty much watching it, monitoring everything that goes on, and that's where you get changes. So anyway, here we go again. Here's just another look at it. We can look at our duty cycle, and then we can look at our current flowing, and right there. So anyway, just be mindful of checking the electronics when it comes to alternators. They're getting more smarter. They get more PCM control, and these cars are having multiple current sensors on them, battery sensors, and that stuff's all important to check before we throw an alternator in a car. Anyway, signing off right here. Hope you enjoyed it. There'll be more to come, and be well. Take care.